We're going to talk about market equilibrium now. This combines the concepts of supply and demand. So market equilibrium determines the price and quantity is going to be produced based on the intersection of the supply and demand curves. When prices reach the level where the quantity demanded equals quantity supplied, we say the market clears. So Q sub D means quantity demanded, Q sub S means quantity supplied. So a graph of the market in equilibrium, we'll do the Pepsi market. Price, quantity on the axes. Make sure you label the axes. You get a point on the AP exam for labeling the axes, the curves, and the data points. Okay, so we've labeled the axes. Then we're going to label the curves, demand and supply, and then where they intersect, that's going to determine our equilibrium price. P star, that's also part of labeling it. P star and Q star, those are your data points. You label them as well. So that would be the Pepsi market in equilibrium, where supply equals demand. Or I should say quantity supplied equals quantity demand. Okay, does everybody have that? Everybody has it, okay? So then we have a surplus. A surplus was when there's excess supply. That's when the sellers can't sell all they want to at a given price. If we graph that, a graph of surplus, it would look like P1 is here. Okay, as you can see from P1, the supply is greater than the demand. Right. So that difference of supply and demand is the surplus. Right? At P1. So what kind of pressure, when there's a supply is greater than demand, what kind of pressure do you think is going to be on prices? Downward or upward? Downward. Yeah, there's downward pressure on prices. So they may go to P2. Right? So, well, first of all, let's go back to P1. Let's quantify it. What would be our surplus?
4.
Yeah, at P1 the surplus is 4, and then we move to P2. What's our surplus now? Yeah, surplus is 2. So on, and then we've got here where they finally we get to P star when supply equals demand. Okay. That would be equilibrium of 4, right? Any questions on surplus? All right, we're going to do a shortage, graph of shortage now. Shortage is when there's excess demand. The people demanding can't buy all they want at price 1. So we look at a graph of that, graph of a shortage. We would start out at P1. the demand is 4, the supply is 1, the difference is the shortage. How much of a shortage is there? Yeah, the shortage is 3. So there's upward pressure on prices now. If demand is greater than supply, then there's upward pressure on prices till we get to P star and Q star. Okay, any questions there? Everybody's got the shortage, okay? The law of supply and demand. Prices will move toward equilibrium. The market determines the price of the good, but there's going to be downward or upward pressure on prices until we get to equilibrium. Law of supply and demand. All right. Change in equilibrium. A change in equilibrium is brought about by a shift in the supply or demand curve. So we'll do some examples. If we graph SUVs and there's an increase in the price of gas, what's that going to shift? Increase in the price of gas. What variable does it shift? What is gas to SUVs? It's a complement. So the price of a complement went up. What's that going to shift? Demand which way? Left. So we shift demand to the left. Okay, so now our new equilibrium, we have our new equilibrium would be at P2 and Q2. Okay. Now when you do the graphs, I want you to number them, 1, 2, 3, 4. You'll see some different variations. I don't like that. Like you might see D and D prime. Which one comes first? We're not sure. You might see D0 and just D, or D0 or D1. You just start with 1. Your first curve is 1. Your second curve is 2. We're going to use 1, 2, 3 numbering system on our graph. So they're all the same. I want them to all be numbered the same. I think that's the most clear thing that shows the order of what things happen. Okay. Again, label all the curves, the demand curve, supply curve, your axes, your data points. Everything should be labeled to get full credit on the graph. All right. Here's another example. Computers, an improvement in technology allows more to be produced. Okay, so what's going to shift here? Why? Yeah, technology. So we would shift supply out. This becomes S1. This is S sub 2. And we have P sub 2 Q sub 2. It's like that. All right, any questions there? We got okay. So now we have, we're going to graph ice cream. There's a heat wave and a hurricane. So you have two things happening here. Heat wave and a hurricane. So we're talking about the Indiana market for ice cream. Indiana market for ice cream. So what's the heat wave going to do?
Increase demand.
Why?
Because it's hot.
Yeah, but what variable?
Oh, quantity. No, supply. No, demand.
Tires or eat it? Which variable? When people like ice cream when it's hot. What is that? Taste, yeah. So demand is going to shift because of taste when it's hot. Right. What about the hurricane? How's that going to affect ice cream?
Decrease.
This is in Indiana, so the hurricane doesn't take place in Indiana, but there is a hurricane.
Decrease supply.
Okay, why?
Because.
What do you use to make ice cream?
Water.
Sugar. Where's sugar? What does sugar come from? Sugar cane. Where is sugar cane grown?
On the
In
coast.
the Caribbean, in the coast where the hurricanes are. So that it destroys the sugar cane crop. So there's less sugar. Okay. So that's gonna. What is that?
Supply.
Yeah, but what variable?
Oh.
Input. Yeah, input price. If there's less sugar, it's going to be more expensive. So we're going to shift supply. I'm going to say it's not as big of an effect. Okay. So this is S1, this is S2. But where we end up, we're going to have a higher price. Oh, I call that S over here. That should have been a P over here on this axis. That's P, P1, and here's P2. You have a higher price, and because of the way I shifted it, the quantity also, quantity also would increase. But what if I had shifted the supply more than the demand? What if the sugarcane effect was bigger than the taste effect? What would have happened? The quantity would go down, right? If I shifted them both the same amount, the quantity wouldn't change. So when there's a change of both demand and supply, then either price or quantity, depending on what combination of demand goes up and supply goes up and down, one of the things is going to be ambiguous, is what we'll call it, or indeterminate. We couldn't, unless they quantified it, we can't determine what's going to happen to quantity in this case. We know without a doubt price goes up. We can say price would go up because it has to. It's up here, but quantity could be anywhere in this range. So that's where we call that the equilibrium quantity could be ambiguous. So price goes up in this case, the quantity is ambiguous depending on the amount of the shift, and we didn't quantify it. So we say the quantity is ambiguous in this case. If there's any time both demand and supply shift, one of the two, price or quantity, will be ambiguous. Okay, let's look at another example of ambiguity. So we had Okay. So we just had what? Supply decreasing and demand increasing. Let's try something different. Let's try, so we'll say they both decrease. Demand decreases. And supply decreases. I'm gonna shift them about the same amount. Okay, so now we're at S2, D2, so we're here. So here's our new equilibrium point. So without a doubt, what changes? Quantity. Okay, what about price? Here's the original price. Now this price, I shifted it in the same amount, so it looks like it's about the same, but we don't know. It depends on how much the shift is, and we just shifted it based on what we felt like. So this, in this case, the price. So we would label this as quantity decreases and price is ambiguous. Everybody get it? Yeah.
And that only works if the shifts are the same.
No, it only works anytime there's a shift of supply and demand. It's ambiguous. You aren't going to know. You know, they're just going to tell you. They would just say supply went up and demand went down, depending on how I drew my graph. If I just drew it because I purposely drew it so the shift was about the same. But if they don't tell me amounts of the shift, they don't quantify it. I might draw it when I draw it. I might draw like this, right? I might have made this shift to here, right? So again, without a doubt, the quantity increased, but the price, it's a gray area. We don't know, depending on how much we shifted. So if it's a double shift, unless they quantify the shift, you're going to say the one that is in the middle is ambiguous. So if you're just trying to sketch it out to see, just shift them the same amount, and the one that looks like it didn't change is the one that's ambiguous.
Is quantity the quantity of like the good of the market?
The quantity, the Q is the quantity demanded and quantity supplied. It's both.
It's both.
Yeah, when they're one at equilibrium. Yeah.
So then when you say Q decreases, like definitely, what does that be the Q of?
Huh?
Market equilibrium. So that's
Quantity.
The equilibrium.
The equilibrium quantity. All right, any other? So when you do a problem like this, sketch yourself, take the time to sketch a little graph. You just try to picture it in your mind. You may not visualize it right, but if you just sketch yourself a little graph, shift the curves, and see what the change is, and you'll be fine. Okay, so that's what we're gonna do. So the remainder of class, we'll do some practice on the shifting. So do number 2 on this worksheet. It tells you a supply or demand change. So I want you to tell me what happens to price and quantity. There's 8 of them. So you should have 8 little graphs on your paper somewhere when you do this. So you can work on that the rest of the class. If you get done with those 8, do number 1 at the top. I also want you to do number 1.
Stop.
What?
It's so funny.
Go down.
The thing is, I haven't found what you have I had like a guy over there, and I could just steal all the second semester last year and this summer, and it was really